So in this discussion, we continue with the atomic structure as we look at now the arrangement of electrons in an atom. So I want you to remember that when it comes to electrons move around the nucleus in a particular orbit, like I said. Now they move very fast, and it is not possible for us to exactly predict the position of an electron in an orbit or energy level, as we called it. But of course, each of an energy level can hold a certain number of electrons. Now, for example, if you go on the periodic table, the elements that are found on the periodic table, they are arranged in order of increasing proton number, starting from hydrogen with proton number 1 all the way to let me say calcium with proton number 20. You are going to find that for the first 20 elements, so I'm just going to look at the first 20 elements in the meantime. That's what I'm going to look at. So for the first 20 elements that are found on the periodic table, from hydrogen with proton, remember this is the proton, with proton number 1 to calcium with proton number 20. So that's the symbol for calcium. I believe you need to go and get to know the elements that are found on the periodic table. Please, you can print out a periodic table so that you can actually become, it should be your good friend that you should be able to use. So now when it comes to the arrangement of electrons in an atom, for the first 20 elements on the periodic table, starting from hydrogen to calcium, the electronic arrangement will somehow look like this. In the first shell, shell or first energy level, you can fill up to 2 electrons. So you can put up to 2 electrons. In the second shell or second energy level, you can put up a maximum of up to 8 electrons, in that second shell. Then in the third shell, you can also put up to 8 electrons. But I'm not saying that this is the maximum. In the third shell, this is not the maximum number of electrons that can be filled up. The maximum that can be filled up is actually 18 electrons. That's the maximum that can go in the third shell. But I'm simply saying that, for the first 20 elements of the periodic table, electrons can be arranged somehow like this. If you have got enough electrons, you can put 2 in the first shell. In the second shell, you can put up 8 electrons. If you still have more, the third shell can also have 8 electrons, in the outermost shell. Let me show you what I mean in this case when it comes to writing the electronic configuration. Let's take, for example, I've got maybe lithium, proton number 3. We use the proton number to write the electronic configuration. So EC, electronic configuration, which is also called electron arrangement. So I'm going to be using electronic configuration. So this EC is representing what I'm calling as being electronic configuration. So whenever you see me use EC, I'm simply talking about electronic configuration, which is the same as arrangement of electrons in an atom. So what is the arrangement? So we use the proton number, the smallest number in this case. So the electronic configuration in the first shell, I've got how many electrons are there? Remember, the number of protons is 3. Even the number of electrons is also 3. So we use those number of electrons to write the electronic configuration. So in the first shell, I'll put up 2 electrons. When I put up 2 electrons in the first shell, how many electrons will I remain with? 1. So that 1, I'll take it into the second shell. So I'm going to have 2, 1. So if I was to draw the structure of lithium, it simply means that in the first shell, I was going to put up 2 electrons. This is lithium. And in the second shell, I was only going to put up 1 electron. And the dots that I'm using are representing the number of electrons. So you can either use dots to show your electronic configuration, as you're going to see, or you can use a cross to show the electrons that are there. So you can see in the first shell, there are 2 electrons. In the second shell, there's only one electron. So this is the way, this is the electronic arrangement, and that's the structure of a lithium atom. So what I've drawn here is structure of a lithium atom. Now, when it comes to the electronic configuration can also tell you a whole lot of things about it. One, if you look at that, it can tell you the group to which a particular element belongs to, and it can also tell you the period to which it actually belongs to. So now, for example, if you look at how many electrons are in the outermost shell, how many electrons do we have in the last shell? Yeah, so the last shell is also called the outermost shell. There's only one, so meaning that lithium is actually in group 1. And how many shells have been filled with electrons? You have 1, 2, so meaning that tells you the group. So remember, the number of electrons in the outermost shell will tell you the group to which a particular element belongs to. How many electrons, how many shells have been filled with electrons will simply tell you the period to which a particular element belongs to. All right, let's try to look at some more so that I can just help you, to familiarize yourself, I'll go to another element which we are calling as being carbon. If you look at carbon C, the proton number is a 6 there. So the electronic arrangement is going to be in the first shell 2, then in the second shell I only remain with the 4. So meaning if I was to draw the structure of carbon in the first shell, I'll put up 2 electrons, and in the second shell I have 1, 2, 3, 4. So if I told you in this case, to which group and what period does this element belong to, so which group, it is yes, group 4, because there are 4 electrons in the outermost shell. And when they tell you in an exam, give a reason for your answer, it is because there are 4 electrons in the outermost shell. Which period? You are right, it is in period 2, because only 2 energy levels have been filled with electron. Let's look at another one I'm calling as being sodium. Sodium, N, capital N and small letter A, has got 11 protons, meaning 11 electrons. So the electronic configuration is going to be 2, I still have more, 8, 2 plus 8, that is 10. I still have more, I'll put up the extra one in the third shell. So if I was to draw the structure of sodium, in the first shell, I was going to put up, just 2 electrons. In the second shell, I'll put up 8 electrons. And in the third shell, I'll only put up 1 electron. That's the structure for sodium. So if I told you to which group does this element belong to, yes, you're right, it is in group 1. And to which period does it belong to? It has 1, 2, 3 shells. Therefore, it is period 3. You can go on and so forth. Let's talk about oxygen. This element, oxygen, it has got proton number 8. The electronic configuration is going to be 2,6. You can see that. Just from there, you can tell me the group, even without drawing the structure. And you can also tell me the period. How many electrons are in the last shell? There are 6, so it is in group 6. And how many electrons? 1, 2. So it is in period 2. Let's look at another one, which we are calling as being chlorine. Chlorine is Cl, and it has got proton number 17. What would be the electronic configuration? Yes, in the first shell 2, you still have more. In the second shell, you can put up 8. That becomes, 10. How many are remaining to make 17? 7. So you take them in the third shell. All right, so this is the electronic arrangement of chlorine. You can even draw the structure. 2 in the first shell, 8 in the second shell, and 7 in the outermost shell. So to which group does chlorine belong to? Yes, you are right, 7, because there are 7 electrons in the outermost shell. Which period? Yes, it is actually period 1, 2, 3. So 3 shells have been filled with electrons. So you can draw that. Let me show you another one. Then we move on and look at something that I want to tell you. Let's take, for example, that I have what I'm calling as being calcium. Remember, among the last 20 elements, calcium is the last one. So it has got proton number 20. So what will be the electronic configuration? In the first shell, I'll put up 2. In the second, I can accommodate 8. That is 10. Again, I can accommodate 8. That is what I meant when I said in the first shell 2, 8. I can also accommodate 8 there. But of course, if you look at it this way, how many are remaining? 2 plus 8, that's 10. 10 plus 8, 18. To make 20, I'm remaining with 2. So if you want, you can draw the structure of calcium by writing all those. In this case, the first shell, you are going to have 2. In the second shell, you are going to have 8 electrons. So we just write them in an orderly manner, but in reality, that's not the way they are going to be. Yeah. Again, in the third shell, I'm going to put up 8. Then in the last shell, I'm going to put up just 2 electrons there. That's what we mean. So this is the structure for calcium atom. So to which group does this element belong to? Well, it belongs to group 2 because it only has 2 electrons in the last shell. Remember, like I said, the last shell is also called the outermost shell. And that outermost shell is sometimes known as being the valence. We call it as being the valence shell. Don't worry, we are going to talk about that in our later discussion. In which period does this element belong to? How many shells have been filled with electron? 1, 2, 3, 4. Or just count 1, 2, 3, 4. So it belongs to period 4. And if you go on the periodic table, you'll be able to see that calcium belongs to group 2 and found in period 4. So that is the way you can do with the electronic arrangement. So I'm going to misbehave in my next discussion. I'm still going to talk about arrangement of electron, but I'm now going to talk about, suppose you go above proton number 20, then how can you write the electronic configuration? So that's what I'm going to look at.